Friends, today we are going to see the soil analysis and the fertilizer recommendations based on soil analysis. Okay, as we all know, the soil is important structure or basic criteria for growing of any crop, and its analysis, it may be a chemical or physical analysis, is very important to plan the fertilizer recommendations for that crop. Generally, what happens is farmer applies the fertilizer dosage based on his experiences or suggestion by, let us say, a fertilizer shop owner. So, but that is not a scientific practice or scientific method of applying fertilizers or deciding the amount of fertilizers to be used for that crop. The best and the most important methods is analysis of the soil and then its interpretation to arrive at a recommended dose of fertilizer. So we are going to see what exactly soil science, why it is soil analysis, why it is required, and how the fertilizer recommendations are being done based on the soil analysis. Okay. Now the first slide is very basic slide. It shows how a plant grows. So whatever the plant may be, the basic physiological function of all plants is almost same. The plant gets nutrients and water from the soil and the sunlight and carbon dioxide with the help of the nutrients and water absorbed from the soil. Uh, the food material is synthesized in leaves, and once this food material is synthesized, the food material gets translocated to various parts of the plant for their growth. So this is the simple process, and it is just a conversion of carbon dioxide and water into sugars and water again. So this is basic principle of growth of any plant. Now as far as the plant growth is concerned, the plant requires n number of nutrients, and the nutrients are roughly classified as follows. From air and water, plant gets carbon, hydrogen, and nitrogen. Carbon is the source of carbon is carbon dioxide present in the atmosphere. Source of hydrogen is water, and source of oxygen is water, and again the oxygen present in the atmosphere. Then the macro or major nutrients, these are nitrogen, phosphorus, and potassium. These are available in the soil, as well as we need to feed them through the fertilizer doses. The secondary nutrients are sulfur, calcium, and magnesium, and micronutrients which are required in very small quantity. These are boron, chlorine, copper, iron, manganese, molybdenum, and zinc. All these nutrients are required for growth of any plant or the satisfactory growth and physiological process of the plant. Okay, so these nutrients play a vital role in the growth of a plant. We can see a plant cell on this slide. Let us take an example of mitochondria, which is at the center, roughly at the center of this cell. Mitochondria is called as the powerhouse of cell. So if you look at mitochondria, you can see the potassium, manganese, ferrous, and phosphorus are required for the growth or for the activity of mitochondria. If one of these nutrients is absent, then it hampers the activity of mitochondria. Indirectly, it hampers the growth of the plant. Okay, so the basic thing when we go for soil analysis is called as pH. A lot of farmers or a lot of scientists talk about pH, but what exactly this pH affects the growth of plant or soil, we'll see in this slide. Generally, pH is a measure of acidity or alkalinity of a soil or water or any solution. So generally, it is measured on a scale of 0 to 14. Agriculturally, it is measured from the scale of 4 to say 10, because very rarely there are soils which are having pH less than 4 or pH more than 10. Okay, the 7 or the center of this scale is called as neutral pH. The pH, if pH is lesser than 7, we call it as acidic, and if pH is more than 7, we call it as alkaline soil. Okay, so if you see at this slide, you will see names of nutrients written on the strips, like nitrogen, phosphorus, potassium, sulfur, calcium, etc. And that strip has a thickness less at some places or more at some places. So what this thickness shows is the availability of nutrient in the soil at that particular pH. If you look closely at this slide, you can see that the pH range between 6.5 to 7.5. At this pH range, almost all nutrients are available in the soil at satisfactory level. Let us take example of 8.5 pH. At 8.5 pH, you can see there is a reduction of availability of phosphorus, a reduction in availability of iron, manganese, and boron. Okay, so as the pH increases from 7, some of the nutrients, the availability decreases. If the pH decreases from 7 to below 7, then some nutrients are deficient in the soil. So this is the pH, because this is important as far as the farmer's point of view. If the soil pH can be kept between 6.5 to 7.5, then the required nutrient availability from the soil will be good, and there will be need of very less amount of fertilizer that has to be applied from the outside. Okay, now when we go see the pH, then it directly affects the fertility of soil. What exactly is the fertility of the soil? You can see in this slide, you can see a plant growing there. The fertility depends on the factors which are shown in the slide. The first is infiltration of water, that is amount of water and how it gets infiltrated in the soil. Second is soil structure. Soil structure is a physical property where the content of sand, silt and clay and their proportion with each other, it gives a soil a structure. Then active soil life, that is microorganism or the life present in the soil. Then the content of organic matter or organic carbon, and then the depth that that we are utilizing for that crop, then amount of minerals or natural elements present in the soil, the pH as we have seen in the last slide, the water retention capacity of the soil, the capacity of the soil to release nutrients for absorption by the plant, the drainage of the soil, and the parent soil from which the parent rock from which that soil is made up of. All these factors, if they are in balance with each other, then we can say that the soil is fertile or our soil fertility is good, or these factors contribute to the fertility of the soil. Now if we go if you see the benefits of soil analysis, the soil analysis most important thing while planning any crop, especially the crop which is high value, because the amount of nutrient and the expenditure on nutrient or fertilizers is of considerable value, and if it is done with the help of soil analysis, then definitely it will save the money. Now the soil analysis, the first benefit of soil is it shows the current nutrient status of the soil, and it can be taken as the basis of the future strategy or how to plan the fertilization of that particular crop. Then if there are some problems in the soil due to alkalinity or acidity, we need to add some ameliorants. For example, some farmers add gypsum or some farmers add lime. So gypsum is added to bring that soil to acidity, and lime is added to bring the soil to the alkalinity. Now, if whether the gypsum has to be added or lime has to be added depends on what the pH of soil is. So the soil analysis shows what exactly the ameliorant which ameliorant we need to use for the soil and its quantity also. Then we see some problems faced by the farmer, that their yield doesn't grow or doesn't increase from a particular level. So there are certain factors in the soil, those factors may be limiting the production. We can find out those factors with the help of soil analysis. Then we can plan something to improve the profitability of the soil through managing the existing fertility of the soil. Then we can plan nutrient for the upcoming crops and we can connect it to the targets which we want from that particular crop, that is target yield. And then once we are finalizing strategies with the help of soil analysis, we need to fine tune the strategies over time. Then repeated soil analysis will help us to fine tune those strategies. And then the soil analysis also helps us to choose the form or application method of a fertilizer. In some forms of fertilizers are not effective in alkaline soil, we need to use some other form, or some method of application is not useful in the soil where the alkalinity is there, so that can be decided with the help of soil analysis. Then the budgeting of the crop can be improved with the help of soil analysis, and all these things together help us a better management of our farm. Okay, the parameters which are being analyzed in this for the soil is generally these parameters are analyzed. Soil is the parameters are classified in physical, chemical, and biological. So in physical, we check texture, that is the content of soil, silt, and sand, silt, and clay, and their proportion with each other. Then water holding capacity of the soil, the porosity of the soil, that is the vacant space between the soil particles, and the drainage capacity of the soil. All these are required as a physical parameters. Then in chemical parameters, we check pH, that is we have seen in the slide. Then electrical conductivity. Electrical conductivity is a measure of salt content in the soil. Then we analyze organic carbon or organic matter. The organic carbon is we can say life of the soil. It is being used by soil microorganisms for their growth, and in turn those microorganisms help the growth of the plant. Then we see calcium carbonate, frequently called as chuna or chunkhadi by the farmers. The calcium carbonate content, if it is more than 5%, it reduces the uptake of other nutrient, and the nutrients like phosphorus and ferrous gets fixed with when if the soil contains higher calcium carbonate. Then we check major nutrients, that is nitrogen, phosphorus, and potash. Secondary nutrients, that is calcium, magnesium, and sulfur. In micronutrients, that is boron, molybdenum, zinc, ferrous, copper, etc. And in chemical parameter, we also check exchangeable sodium percentage. Sodium is required by the plant at very minute scale or minute level. If sodium content is more than say 1 ppm in the soil, it hinders the absorption of other nutrients. For that, we need to check sodium content also. And if required, there are some biological parameters which are analyzed in the soil if there are problems. There are two types of biological analysis we can do. One is microbial activity, that is activity and number of beneficial microorganisms present in the soil. And another is pathogen or harmful microorganisms present in the soil. Okay. Now, once we have analyzed the soil, then and we have a test report with us, then how to read that test report and how to plan our fertilizer strategy. Now in this slide we will see a standard table prepared for the use of farmer. This is very rough method of using the soil analysis report. You can see in the soil analysis, the nutrient content is classified as very low, low, moderate, moderately high, high, and very high. Okay, if our nutrient content in the soil is moderate or moderately high, we have to apply the recommended dose of fertilizer for that particular crop. If it is low, then for that particular nutrient, we need to add 25% more. If it is very low, it will be 50% more. Similarly, if the nutrient content is high, then 25% less than the recommended dose is to be used. And if nutrient content is very high, then 50% reduction in the nutrient content to be applied will be taken into consideration while recommending the dose. Now this method is very raw or crude method. It is prepared for the farmer. Generally it is, we can say, 50 to 7% accuracy, 50 to 70% accuracy we can get from this method. But there are certain other methods which are more precise in nature to recommend the fertilizer dose. So this method is called as soil test and crop response. the crop responds differently, or different crop responds differently to the amount of fertilizer or the form of fertilizer applied in the soil. So with the help of crop response and the soil test report in our hand, we can provide scientific recommendations and guidelines for the fertility management of the soil, and at the same time we can have a sustainable crop production. Now, generally, the fertilizer recommendation or fertilizer application is done to the crop, not to the soil. But we need to think about the soil also, because once that crop is grown or harvested, we have to go for another crop. So while planning the fertilizer dose, we need to check the requirement of the crop as well as requirement of the soil to maintain the fertility of the soil after the harvest of the crop. Now, what this soil test and crop response method does is it develops a relationship between the values which are there on the soil test report and the response of the crop to the fertilizers. Now, it also take into consideration the yield target for making fertilizer recommendation. Generally, in the last table, there is no the average yield was taken as the target, but here we can have a 10% more target or 15% more targeted yield, and we can tune our fertilizer quantity according to the target. Now, all these equations are being developed at research stations by the government, so that the final solutions or final formulae is made available or is being made available to the scientists or to the users which are interested in making fertilizer recommendations with the help of soil test report. Now, it also take into consideration the amount of chemical and organic manures to be used for that particular crop, and it can be used to plan a whole crop sequence, if we test our soil or analyze our soil in the month of May, then we can use that report for the crop which is taken in the monsoon, then the crop which is to be taken in the coming winter season and the incoming the summer season. So this soil test and crop response method is more accurate than the traditional method. Okay, now the target yield concept is being developed or it is being considered while doing this soil test crop response. Now, what the scientists do at the research station is they analyze or they do some research in increasing the yield of the crop, and they come at a point where no yield increment is possible in that particular crop in given circumstances. Now that will be our maximum target, so that target can be taken into consideration while preparing a formula, and these formula are used by the farmers or by the other scientists to arrive at a recommendation. So this is all about how to recommend a fertilizer dose with the help of soil test report. So hope you have enjoyed this video. Thank you.